Hello everyone, we will start today Perkin reaction. Perkin reaction is a special case of aldol condensation. Actually, there are three reactions. One is aldol, and second one is Perkin, and third one is Navinshiel. Okay, so Navinshiel reaction, aldol condensation, and Perkin reaction. Perkin and Navinshiel both are the special cases of aldol condensation. Okay, the spelling of Navinshiel is Knovenagel. Okay, so this is the Navinshiel. So in aldol condensation, what happens? We take two aldehyde or two ketone and we treat them with a base, strong base like NaOH, KOH, and one of the aldehyde group, aldehyde or ketone must have alpha hydrogen atom so that it can form enol. You can first study the aldol condensation. So what happens in the aldol condensation? We take aldehyde or ketone and we take two molecules. Both the molecules may be same or they may be different. For example, I have taken different. So what happens here, one aldehyde must have alpha hydrogen. For example, here this one is having alpha hydrogen atom. So in presence of base, this will form anion or enolate ion. This will be resonance stabilized and you will get CS2 double bond C O negative OH. Okay, so this is a nucleophile and this will attack on the positively charged carbon of this carbonyl group and we get beta hydroxyaldehyde or ketone COH and we get CS2 C double bond OH. Okay. This is actually the product. So what happens here, this carbanion is going to attack, this enol is going to attack on this positively charged carbon atom. That is the basic concept of aldol condensation, and after that when we treat it with acid or base, this is converted into alpha beta unsaturated compound. Hydration, water is removed and this is converted into alpha beta unsaturated compound. And the name of this compound is cinnamaldehyde. So this is the basic aldol condensation. Perkin is simply the modification of aldol condensation. What happens in the Perkin reaction? Let us consider especially Perkin reaction. In Perkin reaction, we take an aromatic aldehyde like this only, CHO, and we take acetic anhydride or any anhydride, CS3, CO, O, CO, CS3. Okay, and we treat it with a base. The base here what we take is CS3 C double O negative Na positive. This is the sodium salt of the acid from which this anhydride has been made. Okay, so when we treat this with base, one H is removed from here, again the enol form is formed, the carbanion is formed, which carbanion is going to attack on this carbon atom, and we get the alpha beta unsaturated compound. Especially we get here cinnamyl acid. Okay, so this is also the same case as in aldol. The change is only here the carbanion or the enol is formed from anhydride, acid anhydride. There it was aldehyde or ketone molecule, now here it is acid anhydride. And in Navangial, what happens? In Navangial, we take aldehyde or ketone. In Perkin, we take aromatic aldehydes or ketone only. Now, in Navangial, we take any aldehyde or ketone, and there we use active methylene group. Active methylene group compounds are those compounds in which a CH2 group is attached with two different or two same electron withdrawing group, a strong electron withdrawing group. For example, here it is diethyl malonate. This is diethyl malonate, DEM. Or we can use this compound also, CH2 CN, and here COOET, OET. Okay, so these two are strong electron withdrawing groups, and when we take a base here we use is 1 degree amine or 2 degree amine or pyridine, pyridine or piperidine. Okay, so in presence of these bases, this hydrogen is removed from here and it will generate a carbon ion, and this carbon ion or enol, and this enol will now attack on this. Okay, so in these three reactions, aldol, Perkin and Navangial, all in these three there is a enol formation, and that enol attacks on the carbonyl carbon to form alpha beta unsaturated compound. Okay, so all these three are same type of reactions. Now we will start with the Perkin reaction. So now this is the Perkin reaction. We will start from the beginning. Perkin reaction. So Perkin reaction is a special case of aldol condensation. Okay. In Perkin reaction, what happens? We take a aromatic aldehyde with, we take aromatic aldehyde and we treat it with acid anhydride in presence of a base. And what is the base? The base is salt of this acid, from which this acid anhydride has been formed. Okay, and what we get? We get alpha beta unsaturated. What we get is alpha beta unsaturated acid. Okay, and this reaction is known as Perkin reaction. Means in Perkin reaction, the aromatic aldehyde is treated with acid anhydride in presence of sodium or potassium salt of that acid to form alpha beta unsaturated acid. Let us take the example. Suppose this is benzaldehyde, this is a aromatic aldehyde, and when this is treated with CS3 COO C double bond O CS3, this is anhydride, this is acetic anhydride, this is acetic anhydride. Okay, when it is treated with acetic anhydride in presence of sodium salt of acetic acid, so we get alpha beta unsaturated acid, and that acid is cinnamic acid, CH double bond CH single bond C double OH. This is cinnamic acid. Okay, and acetic acid is also formed as a side product. So the main product is cinnamic acid, which is alpha beta unsaturated acid. Okay, let us take one more example. Okay. Suppose there is a compound O and here it is CHO, right? And when we treat this compound with MeCO whole twice O and MeCOONA, and it is heated to 140 degrees centigrade. Okay, so This is the reaction. This is acetic anhydride. Me means CS3, and this is salt of the acetic anhydride. So what product is formed actually? The product formed is CH, double bond CH, single bond COOH. This is aromatic aldehyde, and this is alpha beta unsaturated saturated acid. Okay. Now we can also observe the mechanism of the reaction. Let us see how the reaction proceeds. Mechanism. The first step of the mechanism is removal of hydrogen from acid anhydride. This is acid anhydride. Okay, and here one H is there. So in presence of base, what is the base? CS3COO negative. This is the base, and in presence of base, this hydrogen is removed. Okay, why we use this base? Why not NaOH or potassium hydroxide as in case of aldol? If we use those strong bases, this aromatic aldehyde can undergo Cannizzaro or aldol type of reaction. Since it is aromatic, it is not having alpha hydrogen, so it can undergo Cannizzaro reaction. But in presence of weaker base, there is no chance of undergoing Cannizzaro reaction, and this weaker base only abstract hydrogen from this. So we will get a enol ion, a carbon ion is formed, CH2 negative, C double bond O, O, CO, CS3. Okay, this is resonance stabilized. Okay, this will be resonance stabilized. This will come here, this will go here, and we will get CS2 double bond C, O, O negative, O. This is the enol form. Okay. Now this will attack on the carbonyl carbon of our aromatic aldehyde. This was our carbonyl carbon, double bond O, H. Okay. So now this will attack, this will come here, and this will attack on this carbonyl carbon, and what we get is this will attack on this carbonyl, this enol will attack on this carbonyl carbon, and what we get is CO negative, and then H, and after that this CH2 will be attached over here. So CH2, C double bond O, O, C, O, CH3. Okay, this carbon is attached with this, and this whole group is here. Okay, so this is the attack of this nucleophile on this positively charged carbon atom. So this was the species formed by attack of the enol ion, enolate ion, or negatively charged nucleophile generated from acetic anhydride on the aromatic aldehyde. So this species is formed. Now this species has acetyl group, CS3CO group, this group on this carboxylic oxygen. Okay, so the acetyl group from carboxylic oxygen, it is transferred from this carboxylic oxygen to this alkoxy oxygen, because that will be a more stable species. So there is a transfer of acetyl group from carboxylic oxygen to alkoxy oxygen. How it takes place? Let us see. This is the species. Okay, and here CH and O negative. and there is CH2, CO, O, and now there is COCH3, and a negative charge is here. Now this was the negative charge and this is COCH3. Now this lone pair attacks on this carbon, okay, and we get this is converted into a cyclic structure CHO, CO, CO, CH2, CH2, and this is converted into O negative, right? So this species is formed, this oxygen attacks on this carbonyl carbon, and in the next step this lone pair reverts back. Two lone pairs are here, so it reverts back and this bond is broken, okay, and this bond is broken and this COCH3 group is transferred on this oxygen. This COCH3 group is transferred on this oxygen. So what happens in the next step? We get, okay, we get this, and this is CHO, O, and then it is COCH3. This group is attached to alkoxy oxygen, and we get CH2, C, double bond O, O negative. Here we get O negative. Okay, this bond is broken and both the electrons goes on this oxygen. So this is converted into negative, O negative. So this is the group. Next, what happens? This hydrogen which is here, it is removed in the form of H positive ion, and this bond is broken. This oxygen goes with this oxygen, this bond is broken, this hydrogen gives its electron here, and ultimately what we get is O, C, okay, and then H. Here double bond is created, double bond CH, single bond C, double bond O, O negative, okay, and this O negative takes this H and it is converted into OH. So this is actually alpha beta. This is actually what happens. You can see this is actually alpha beta unsaturated acid. Okay, what is happening over here? This proton is lost and double bond is created here, and this CH3CO group is eliminated. This is the leaving group, and this H goes over here, and we get alpha beta unsaturated acid. So this is actually the case of Perkin reaction. So this was the mechanism of Perkin reaction. One more example we can take. Suppose we have a compound aromatic aldehyde CHO like this, and OH group is also over there, and when it is treated with CH3CO twice O, this is anhydride, and CH3COO-Na. So the first step will be the attack over here, and we will get OH, and we will get CH double bond CH and C double OH. Okay, alpha beta. This CHO is converted into alpha beta unsaturated acid. Okay. Now this acid and this OH will react and they will form ester, lactone. Cyclic ester will be formed. So we will get this. Okay. So this is the example of what? Perkin reaction. Okay. One more example we can take. C6H5CHO and when it is treated with CS2, CS3, CS2, CO twice. So this is propanoic anhydride in presence of CS3, CH2, COO Na. Okay, the sodium salt of the anhydride, and heat. Then what will happen? The alpha carbon will be attached because the negative charge, the anion will be formed from here. So this carbon will go and will be attached here. So we will get C6H5 and CH. Okay, and after that, this C will be attached over here, C6H5CH, and the double bond C, this carbon will be attached, and CS3 will be here, and CH, sorry, not H, COOH. Okay, so this CS3 is this one, and this carbon has attached over here, and we will get this methyl cinnamic acid. Okay, thank you.